Yes. Sorry, I wasn't really positive if it started. Usually that's what happens on the laptops, right? It doesn't happen on the phones that way. So I come across this searching. I come across this piece of paper. I did all the programs in like 2 days, and I didn't even win. And you had a month to do it. And I did every single one of them in 2 days, and I didn't win. And they let the Down syndrome patients win. That's not what this is about. It's what's written on this piece of paper I found that is quite remarkable. If you see, it says see backside, ask Google, what is the molecular mass of our sun divided by the mass of the sun? Now, I didn't just ask Google that. I figured it out myself. But I didn't really figure it out because I think I was actually just on the ward at the time I was doing this, and I just wrote that there to see if my answer was right. But I actually figured out how to do that. Now, this is funny. I'm going to actually do this now with my phone here so we can see if I'm anywhere close to positively charged, with this. But just listen to this. You're gonna like this. So now first you're gonna think, yeah, we know, but just wait. How many moles of hydrogen and helium with full valence shells are in the sun? Now, what I mean by full valence shells in there is with nuclear fusion, how's that hydrogen and helium doing with a full valence shell? The hydrogen, right? To connect to that helium and stay there. That's a little theoretical yield, right? We don't really know. Now, first I'm doing molarity, molecular mass divided by mass, but the equation in Avogadro's perspective, 6.022 times 10 to the 23rd of, that'd be the number of helium and hydrogen atoms divided by the size, right, of the sun. So we have to know the size of the sun now. So how much helium per mass in ratios, molecular mass, atomic what does AMU stand for? Atomic measured units or something per mass. I forget what they used. Measure size. Now, find out how many hydrogen and helium can fit in that size by dividing the molecular, the AMU, and mass, right? But use ratios to do this with stoichiometry because that's how you find out the molecular mass in the first place with the elements. Now, I don't know if there's different elements in helium and hydrogen there, but I'm just doing that because, we're told that's what it is, right? I don't know. You can ask later. Now, Hess law I'm going for. And I say Gus dumb answer here, so I must have been doing this in my room. So 2H plus 19E negative plus H plus HE negative. Am I attempting the actual formation? It does say that at the top, how it's formed. I didn't want to read that because I thought it was stupid, but no, that's what I'm doing. First conjuring in center, right? Unstable, like I said with the full valence shell. Isotope with electrons, but eventually move through to get 10. But there would be an extra one. That's why it exploded. Colossal force, I guess, because it donated a proton, right? So there's, in the hydrogen and helium in the center of the sun, there's 2 protons moving back and forth between the hydrogen and helium, that means, possibly. And that's just me figuring that out now as we speak. I didn't look that up. They are both negative. They have to be, considering that. 2 hydrogen elements can somehow manage to become full valence shells, maybe, except one electron on the valence shell of the first two hydrogens. Maybe there's two hydrogens. No, there was only one, right? That's what I just said. This is me in advance, right? Then another hydrogen atom electron attached to the valence. Maybe that's how. And the shell, and they became locked. Together, 3 more electrons grabbed hold and made this molecule whole. Over time, the proton of one of the 8 hydrogen atoms fused to create helium. They remained together, unable to separate. So here's my little final product of center of the sun. H9 positive plus He11 negative arrow, E and in brackets, like top script brackets, plus negative, and then underneath it H10 negative plus He9 negative. I don't think I did that right, but you try it. Let's see if we can do it with the phone. If that worked to figure it out. So, hey Google, hey Siri. I don't have that set up yet. So, my Wi-Fi's off. Okay. Hey Google. Hey Siri. Hey Siri. Hey Google. No, it's not even working yet. Okay. Oh, I see. Wait, hold on. Hey Google, what's the molecular mass of the sun? The sun is a star, not a single molecule. So it doesn't have a molecular mass in the same way a molecule does. Instead, it has a mass of approximately 1.989 times 10 to the 30 kilograms. Its mass primarily composed of hydrogen and helium, which are much lighter than the atoms on the Earth. Oh, so the sun is very light compared to the Earth. But all right, let's. Hey Siri, how many hydrogen and helium atoms can fit inside the sun? The sun contains an immense number of hydrogen and helium, estimated to be around a few times 10 to the 56 to 10 to the 57 atoms in total. With roughly 91 to 92% being hydrogen and 8 to 9% being helium by the number of atoms. These figures can be calculated by taking the sun's total mass, applying the percentage of each element of by mass, and using Avogadro's number to convert the moles, and finally to atoms. Yeah. So that's okay. So if there's no if there's 91, I'm going to say 92% hydrogen and 9% helium to make it bigger, the number of atoms, right? So what's the mass first? And then we'll see now we're ratioing it out. Okay, so now we're doing ratios. Hey Siri, what's the ratio of the number of hydrogen and helium atoms in the sun? The ratio of hydrogen, 11.5 to 1. All right. So that's like 1 helium, right? Okay, so 11.5 and 1. All right. Hey Siri, how many hydrogen atoms with the ratio? What was the ratio? 11.5. Hey Siri, how many hydrogen atoms are in the sun with a ratio of 11.5 to 1? The number of hydrogen atoms in the sun, steps for calculation here. Determine the mass of hydrogen. The mass is approximately 1 That's what it said. Convert the mass of hydrogen to grams. Ah. Yeah. I haven't learned this type of thing yet. This is university shit. Final answer. The number of hydrogen atoms in the sun is probably approximately 8.93 times 10 to the 56. Well, if that's true, then in a gaseous state, the Earth is only 6 million trillion atoms bigger than the Earth. That's atoms, million trillion. That's like nothing. That's like not even enough to make a piece of meth. You know that? Oh, 8.93 times. Okay, not 6.022, right? All right, so to 1. That means put 1 more, so that's 57. Right? So 8.93 times 10 to 57 divided by, I have a pen to write this down anywhere, anyone? All right, so let's just write it somewhere here so that I know what to ask for, so I don't forget. I'll write the comments. 8.93 1057. All right. Hey Siri, how big is a star in grams? The mass in grams is 2 times 10 to the 30 kilograms, which is about, all right, they're giving me bullshit. 1/10 to some mass. I said grams, not kilograms. So coding kilograms to grams would be adding more zeros. How many more? 3 more. So that would be 2 times 10. Hold on. Hey Siri, what's 8.93 times 10 to the 57 divided by the mass of the sun? And that is, the final answer for that is 4.489467 times 10 to the 27 kilograms negative 1. As a, what is the mass of the sun in I want grams. Tons. They don't want to give me the grams, they want me to, okay, if it says kilograms, then we can, they want to do it in that, yeah, because I don't know how they do things in, university, but what I was taught is always to do grams. Anyways, I gotta go. Peace out.